Taking a look at our outline, this is a big unit. We're going to talk about sediments today, and then in the next lecture we're going to talk about erosion on land. Sediments and erosion are quite closely related, but I split them into two groups for our discussion today and in lecture number 12. So here we are in lecture number 11. We're talking about sediment. Sediment is one of three major sources of water pollution in rivers, streams, lakes, reservoirs, and estuaries in the United States. Sediment pollution is pretty widespread, and it doesn't really matter where you go in the United States or throughout the world, you're going to see sediment pollution in our surface bodies of water. Here's an example of sediment floating in a stream as it connects with another stream. You can see the turbidity in the water. Definitely this is not a positive sign for water quality. Here's another picture of sediment pollution. Here you have a tributary of water, or it could be a mining operation, but it's something that is disturbing the soil adjacent to this water body, and you can see all the sediment floating in the water. Certainly this is not good for the aquatic environment. Sedimentation is a global issue that tends to be associated with agriculture. Agriculture is probably the major cause of sedimentation, but there are other major causes of erosion. Sediments and erosion are closely related. However, the issues will be covered in different lectures. We'll talk about sediment today, and then when we go to lecture 12, we'll talk about erosion from the land. Well, again, sediment pollution can be pretty striking. Here's sediments floating in the water adjacent to a land mass, which is probably causing the sediments to be in the water. Lots of times we have storm runoff or runoff from sewers, and the effluent of water is pretty sediment laden. So here we have sediments going directly into a surface body of water that's already in pretty bad shape. You see the algae and stuff like that. When we talk about sediments, we need to talk about two different dimensions. There's two dimensions associated with sediment pollution. We have a physical dimension and we have a chemical dimension. Let's start out by talking about the physical dimension. The physical dimension, the sediment comes from the land, topsoil loss, and land degradation by processes like gullying, sheet erosion, real erosion. This loss of soil by these erosional process leads to excessive turbidity in the receiving waters, and thus we get sediment erosion. In some areas of the world, we lose a lot of topsoil, and this puts a lot of sediment in rivers and streams that eventually get to the oceans. Erosion has shaped landscapes. In severe cases, you see gullying, where gullies have been created. What once was fairly flat land, we see big gullies. We can see severe erosion on farmlands. Here's a picture of farmland where the type of erosion we see is gully erosion. Pretty extensive, and when you add up those soils, the amount of soil loss on an annual basis, you can see why we have so much sediment in surface bodies of water and why it's such a problem. Lots of times on the edge of fields, agricultural fields, we have lost lots and lots of topsoil or soil, and here you have some major gullies, and these gullies are deeper than the human standing here. So as we look at the landscape, we can see that erosion has carved a lot of sediment out of the landscape. Here we see a little depression in this picture, and all that sediment went someplace. It probably went down a river, and it degraded our rivers and surface bodies of water. There are many places in the world where we have excess sediment in our water. Here's just two simple examples compared to each other. Here we have on the left where we have low loads of sediment in the water, and you can see the water flowing over this weir. The water is a little bit colored. It's not completely clear, but it's not tremendously laden with sediment, as opposed to the picture on the right, where the water washing over the weir is just heavily laden with sediment, and there are repercussions of all this sediment in our surface waters. So this physical dimension is something that we need to be pretty concerned about. The physical dimension, or the sedimentation, leads to off-site or surface waters. It leads to negative ecological and negative physical impacts from the deposition of these sediments. Eventually they go down the river, they're floating in the river, but eventually as rivers slow down as they get to their mouths, the water flow slows and the sediments drop out of the water and deposit themselves. And oftentimes where this sediment is deposited causes problems with the ecological landscape and with human activity. And this is what we're going to cover in this lecture, sedimentation. This looks like a flat plain, but actually we're in a reservoir in Morocco. This reservoir at one time was over 30 feet deep. Today, the reservoir is basically filled in. You can see in the back left, there's a little bit of water you can still see in the reservoir. But basically, this reservoir is filled in with sediment, and it's lost its useful purpose. So we definitely have this physical dimension. In addition to the physical dimension that we need to be concerned about sedimentation, we have a chemical dimension. The small soil particles that are part of the sediments in the system, they're the silt and the clay fractions of soil, carry chemicals. The nature of silts, and particularly clays have negative particle charges, and they carry elements that stick to them or that are positively charged. For instance, silts and clays, particularly clays, carry phosphate, so they're a source of phosphorus pollution. They carry ammonium, which is a form of plant-available nitrogen. They carry positively charged pesticides, and they carry some of our heavy metals. And basically, the silts, and the clays carry these absorbed chemicals, which are transported by sediments into aquatic systems. Definitely a form of chemical pollution. We will talk specifically about the chemical dimensions in other lectures. We talked about nutrients in last lecture, lecture 10. We'll talk about eutrophication in lecture 17, and we'll talk about heavy metals in lecture 13. Now, the amount of sedimentation or sediment carried by rivers across the world is massive. It's estimated that global sediment loads to the ocean exceed 40 billion tons of sediment per year. And there are two hotspots in the world. About 30% of the sediment load comes from rivers of Southeast Asia. Remember, Southeast Asia is a heavily populated area of the world, and the relief of the area is quite high relief. So you get a lot of water movement down the road, down the rivers. Also, you get a lot of precipitation in Southeast Asia, so there's a lot of water carrying. And about 45% of the world's sediment load comes from erosion associated with the high relief portions of elevated islands in Oceania. So our hotspot, 75% of the world's erosion basically comes from rivers of Southeast Asia and the mountainous terrain in islands in the South Pacific. So remember, it's estimated that global sediment loads to the ocean exceed 40 billion tons of sediment per year. It's the human influence in Southeast Asia and Oceania that caused this disproportionately high percentage of the total global load. So it's human activity that really accelerates erosion and makes Oceania and Southeast Asia erosion hotspots. And we'll take a look at some data about this in a few moments. I don't have any recent data. The last time there was good data that was published that compared different river systems in the world was in the late 1960s. I would assume that these numbers, if anything, have increased because the population's increased. So the data I'm going to show you is pretty old, but it shows the impact of sediments in different parts of the world. If anything, the sediment values shown in the next two tables are low because populations have doubled in the past 50 years, and our erosion control measures have not really improved that much in these wet areas of the world. So let's take a look at some of the world's major rivers that have huge sediment loads. Let's start out with a river that just, when you think of the name of the river, you think sediment. We'll start out with the Yellow River in China. It's estimated that the average annual suspended load of sediments in the Yellow River is over 2 billion tons a year. That's huge. That's 1/20th of that 40 billion ton worldwide load. And if you take a look at a picture of the Yellow River, if you Google Yellow River and Google images, you'll always see a river that is basically yellow to red in color because it's so heavy in sediment. Here's a typical picture of the Yellow River in China. We go to the river with the second highest sediment load in the world. Again, it's the Southeast Asia River. It's the Ganges River in India, which carries a sediment load of about 1.6 billion tons of sediment per year. Just a tremendous amount. If we take a look at an aerial picture of the Ganges River near the delta, we can see that when times are good, sediment loads are pretty low. But most of the year, particularly in the wet and monsoon seasons, you can just see tremendous amounts of sediment in the river. We keep going and looking at other rivers with very high sediment loads. We go to Bangladesh and look at the Brahmaputra River. Average annual sediment load is 800 million tons. This river not only has a high sediment load, it has a very high trash load. It's very polluted. Here's a look at Google a picture of this river in Bangladesh. You don't see so many sediments in this particular picture, but you see all kinds of trash in the river. So it's a heavily polluted river. We go to the river that ranks fourth in suspended sediment loads. We go to the Yangtze, the other large river in China. The Yellow and the Yangtze rivers are the two major rivers in China. Average annual sediment load is over 500 million tons. And any picture you Google of the Yangtze River in China, you're not going to see clear water. You're going to see a river that's laden with sediment. And, the Yangtze River flows through large agricultural areas. So a lot of this runoff is coming from the steeply farmed agricultural land around the river. So we've gone through 4 rivers, and they're all in Southeast Asia. We can keep going. The next highest sediment-laden river in the world is the Indus River, which is the major river in Pakistan. If we take a look at photos from the air of the Indus River, you see tremendous amounts of sediment. Pretty amazing. Now, I wanted to get out of Asia and look at a couple rivers for comparison. Let's go to North America. Not ranked 6th, but ranked 8th in highest sediment load in the world is the Mississippi River. The Mississippi River carries about 340 million tons of sediment per year. And we think of the Mississippi as being a pretty muddy river, but it's not that bad compared to these rivers that rank higher than it. So Mississippi is the 8th largest sediment load river in the world. Looking for pictures of the Mississippi River when in dry seasons, the sediment settled out and the water looks pretty clear. In the spring, when we have massive runoffs in the Mississippi River Basin, the river looks pretty muddy. And the next North American river that I can find data for is the Colorado River. It's the second highest sediment-laden river in North America. its annual sediment load is about 150 million tons. And the Colorado River doesn't carry as much water as many of these other rivers, but its sediment load looks pretty significant. If you've ever been to southwestern United States and seen the Colorado River, you know that it's not really that clear. It's pretty sediment laden. If we look here in the Pacific Northwest, the major river in the Pacific Northwest, of course, is the Columbia River. The Columbia River doesn't get in the top 50 rivers as far as sediment load. If you really wanted to look for sediment load, you have to take a look at an aerial photograph of the ocean and look at the mouth of the Columbia River. And from aerial photography, you will see plumes that show the sediment delivered to the oceans by the Columbia River. But again, the Columbia River is not a major sediment producer compared to many of the other world's rivers. So the table I showed you is pretty shocking. Sediment loads are pretty high. The previous table shows that huge amounts of sediment is carried, particularly by the big rivers in Asia. Two large, most sediment-laden rivers in the United States only rank 8th and 14th in the world as far as total sediment load. That would be the Mississippi River and the Colorado River. We see some big rivers that aren't on this list. We think of the Amazon River, definitely one of the 2 or 3 major rivers in the world. It ranks 7th. It doesn't rank that high. It doesn't rank that high because the Amazon basin has agriculture. It has land clearing in it. But the Amazon basin is pretty flat, and there isn't as much sediment delivery. The Nile River, the other major river in the world, isn't ranked in the top 16 as far as sediment load because as it flows north through the desert in Africa, the elevation is not very high, so you don't get that much sediment runoff from the land, and there isn't as much agriculture along the Nile, except for that strip in Egypt, so you're not producing that much sediment load. So the 16 major rivers of the river systems, and again, I put about half of them in the table, each transport more than 100 million tons of sediment per year. Now, that table that I showed you doesn't tell the whole story because the sizes of those 16 watersheds differ greatly. To realistically compare these basins, we need to take a look at the suspended tons of sediment per square mile of the watershed. Because some of those watersheds are smaller, some of them are massive. So if we were to re-rank those basins based on suspended sediment load in tons of sediment per square mile of the watershed, our ranking changes a little bit. So let's look at some of those numbers. A tributary of the Yellow River in China, remember the Yellow was the highest ranking river as far as total sediment load, is the Qing River, and the Qing carries about 20,500 tons of sediment per square mile of the watershed. That's a tremendous amount of suspended sediment. We look at number 2. It's also a tributary of the Yellow River in China, the Low River. It carries 20,200 tons of sediment per square mile of the watershed. We keep going down. We've got the Yellow River in China, 7,500 tons of sediment per square mile of watershed. So you can see that the 2 Yellow River tributaries carry almost 3 times as much sediment per square mile as the Yellow River in China. We keep on going down this list. The Ganges River in India, which again was in our top 8 rivers, on a per square mile basis, it carries about 4,000 tons of sediment per square mile of watershed. The Brahmaputra River in Bangladesh, about 3,700 tons of sediment per square mile of watershed. So you can basically see that the Southeastern Asian rivers carry a lot of sediment and carry a lot of sediment per their size of their watershed. Huge numbers. Colorado River would rank 12th. It carries about 1,000 tons of sediment per square mile of watershed. And if we had to rank the Mississippi, it would rank 20th. It carries about 280 tons of sediment per square mile of watershed. So this table kind of tells you that, these rivers that carry the tremendous amount of sediment on a per square mile also carry an awful lot of sediment. So if we use the tons per square mile metric, it makes the Asian River stand out even more. The Yellow River, which runs through China's Los Plateau, which Los is soil that's primarily composed of silt, is very erosive, and it's full of sediment. And there's a lot of farmland there. So you've got intensive farming, you've got soils that are highly erodible, and as a result, the Yellow River aptly is named because of all the sediment from the Los Plateau that it carries. So basically, sedimentation is a major problem. Now, I said that Oceania, that area of the world, probably has 45% of the world's sediment carrying capacity. We have to realize that a lot of these oceanic countries are islands. They have short rivers that are not big basins. So they don't really, it's really hard to get good data just to show how much sediment is moving off of these islands in the South Pacific. So sediment as a physical pollutant impacts the receiving waters in following ways. It creates high levels of turbidity, which make the water less clear. And that's pretty bad for the aquatic ecosystem. And we have high levels of sedimentation, which is a negative. When that sediment falls out, the rivers are much less productive. If we take a look at the high levels of turbidity for a few minutes, when the waters are turbid, which means they're not clear because they're full of sediment, the turbidity limits the penetration of sunlight into the water column. That will limit the growth of things like algae, which we probably want it limited, but it limits the growth of rooted aquatic plants in the bottoms of these water bodies. And these aquatic plants in these water bodies are really important for fish, important for aquatic habitat. So we don't have the aquatic habitat that we would consider optimum. Consequently, when you don't have the aquatic plants in the river, you limit the growth of fish. In spawning rivers, in rivers where fish spawn, the gravel beds at the bottom of the water body are really important because that's where fish lay eggs and things. Well, if you've got sediment covering those gravel beds, you don't have any place for the fish to lay their eggs. And it prevents spawning fish from laying their eggs, and thus the aquatic habitat is not as good, and the fishery is not as good. So high levels of turbidity basically cause a disruption of the aquatic habitat. Turbidity has both negative aesthetic and economic impacts on aquatic ecosystems. Research has shown significant negative impacts on turbidity on studied surface water bodies. So that's well documented. There's hundreds of articles in the scientific literature that document the negative relationship between turbidity and the productiveness of surface bodies of water. One of the organisms that's really negatively impacted by turbidity in streams are what we call macroinvertebrates. Macroinvertebrates are these really tiny invertebrates that live on the bottoms of rocks or live on rocks in surface bodies of water. Fish and other organisms depend on these macroinvertebrates for food. You wipe out the macroinvertebrates and you have much less food. Traditionally, and Currently, we go out to rivers, and one of our measurements we take to determine the quality of water in rivers is to take a look at macroinvertebrate populations. They're a great indicator species of water quality in streams. Where sediments are present at the bottom of streams, or sedimentation is where the waters are turbid, the diversity of macroinvertebrates decrease within the stream, and that's a good indicator that the fishery is not in optimum. You lose macroinvertebrates, the macroinvertebrate diversity, it results in a decline in the aquatic environment and a decline in the fish numbers within the stream. Okay, in addition to turbidity affecting the aquatic ecosystem and the fishery, high levels of sedimentation cause a physical disruption of the hydraulic characteristics of river channels. And this can have a negative impact on river navigation. It can have a negative impact on floods. It can have a negative impact on many things. If we take a look at a change in system hydraulics, here we have a slow-flowing river. We start to put more sediments in the river, and we change the characteristic of the river. We end up with sandbars. We end up with all sorts of things that are less desirable. You can see that the stream has spread out compared to with small amounts of sediment. As the stream spreads out, the depth of the stream also decreases. So a lot of sedimentation in streams can result in reduced channel depth. This reduced channel depth may also increase the risk of flooding. When I say it negatively affects flooding, I'm talking about the fact that you're more likely to have flooding when you have more sediments in the water body. This can be easily explained by looking at a cross-section of a stream. Here we have a stream bed down here. Here we have the flowing water, this cross-section, and at the bottom here we have sediments that are piling up. As the sediments keep piling up, there's less flow room for this stream. So this stream has a lower water carrying capacity today than it had when we did not have the sediments deeper in the water. So we have a reduced water capacity. That means we're more prone to flooding. So when we have those big storm events or the big runoff events from snowmelt, it's easier to flood that river valley. So sediments can have a big impact on a stream. You start putting sediments in water, and you start seeing the change in hydraulics of the river. You see all sorts of changes, and many of these changes are not for the better. To combat sedimentation in rivers, the buildup of sediment, humans have resorted to a process called dredging. Dredging is the removal of silts and other materials from the bottom of water bodies. There are a lot of different dredgers out there, but basically a dredge machine is basically a machine that either floats on the water or is in a boat, and it goes out and it removes sediment from the bottom of the water body. You removing the sediment to make the channel deeper, usually for navigation. And water bodies are routinely dredged in highly developed countries, and you see dredging also occur in middle and less developed countries. Water bodies that have been dredged include rivers, pretty common, harbors because of shipping, lakes have been dredged, even shallow ocean waters have been dredged to keep the shipping channels deep enough to transport goods across the planet. So here's a picture of a real dredge in action, basically trying to keep the water body deeper so that it can handle ships. Dredging is commonplace. It's considered a necessary process due to extensive erosion and sediment migration from land to water bodies. So we've been dredging for well over 100 years. It's an important process to keep our shipping rivers open and to keep our ports open. Without sedimentation, we wouldn't bear this cost, which in the United States costs several $billions of every year to do our dredging. Here is a working dredge. You can see the dredge is picking up sediments from the bottom of the water body, piling them in a barge, and then the sediments are moved someplace else. So dredging is not something that most people like. It usually focuses on keeping rivers navigable. So humans use practices that generate huge sediment loads in water bodies. So we have practices, erosion practice things that cause all the sediment going into our water bodies. That sediment that settles in these water bodies must be removed. Dredging is an ongoing process, and in some rivers, dredging occurs all the time. You start at the top of the river, remove sediments. Once you get to the mouth of the river, you go back upriver and start all over again, because the amount of sediment is so massive. Even if humans reduce sediment loads in rivers, dredging would probably still continue to be important. And it would probably even increase even if humans decreased events that caused erosion, because we depend on shipping to transport goods for trade across the world. And if we take a look at our harbors, the ships keep on getting bigger. They are getting bigger and they have bigger drafts, so they need deeper depths to moor in harbors. If we just look at the United States, we have massive ships that carry the bulk of goods imported in the United States. To receive these goods, we have to have harbors that have that are deep. So harbors must remove sediment that could ground ships. Here's an example of a ship in the United Kingdom that was grounded. Sediments were too high, ship got stuck. So dredging is a practice that's pretty common. Dredging is basically a four-step process. You've got a dredge that digs into the water. It loosens the sediment material. After it loosens it, it brings it to the surface. Then the material, they transport the material to an off-site place and then dispose of the material. Within the United States, the agency that's most involved in dredging is the U.S. Army Corps of Engineers. It's the major player in dredging in the United States. Now, the Army Corps of Engineers doesn't do all that dredging. Most stuff is contracted out to private contractors. But the Army Corps of Engineers determine what needs to be dredged and basically fill out all the environmental permits associated with such processes. So with dredged sediment, the U.S. Army Corps of Engineers issues permits for the disposal of the dredged sediments. And of course, since rivers and harbors are environmentally sensitive, the U.S. Environmental Protection Agency is involved, and it provides oversight and authorization for the disposal of the dredged materials. Now remember, in those dredged materials, we can have lots of pollutants. We can have heavy metals, we can have toxic chemicals, we can have pesticides, we can have nitrogen, we can have phosphates. So we need to we need to look at our dredged materials quite often. Within the United States, the top priority areas for dredging are the Mississippi River. Remember, it's the most heavily laden sediment river with sediment in the United States, and it's a big shipping corridor. And in the Gulf Coast, from Texas all the way to Florida, the harbors are pretty shallow, and sediments cause a major problem, so those ports are often dredged. So as you go up and down some of our major rivers in the United States, this happens to be on the Mississippi River, you see dredged material piling up for removal. Dredging is not a cheap process. Depending on the situation, dredging costs range anywhere from $5 to $30 per cubic yard of material moved. The cost is very high, but the value of dredging is also important. There's over $13 billion in port jobs in the United States that are dependent to keeping these ports open. So port dredging is important. And from the United States, we export 2.4 billion tons of cargo. And we need dredging in those shallow harbors to get those export cargo out of port. So it's a process. It's a necessary evil. Dredging continues to be an important process, and much of the process is caused by sedimentation, human practices which cause a lot of sediment movement throughout the country. Now, our problems are minor in the United States compared to the situation in Southeast Asia, where heavy precipitation, intensive use of farmland, and large populations cause huge sediment loads in rivers. So we're going to move on to in the next lecture, we'll talk about the actual erosion of these sediments on land. Where do these sediments that end up in our rivers come from? Thank you for your attention. Move goods up and down them, and it's usually focused on keeping harbors deep enough for ships that transport goods around the world. Today we're going to continue on our section in surface water quality, talking about pollutants and measurements.